Okay. So if Darren wants to spend no more than $100 on trips to the amusement park, how many visits can he make if he buys a membership? How much did it cost him to buy a membership, CJ?
$50 each.
Now, is he going to spend that $50 once or multiple times?
Multiple times. I mean, what?
He only has to buy the membership one time and he has a membership, right? 50. If he buys a membership, how much does it cost him to go to the park each time?
$25.
Not if he's a member.
I mean, $15.
Right. Normal admission is $25. Admission for members is $15. So notice it started at $50 and then we're adding $15. Do you know how many visits he's going to make though?
No.
It doesn't tell you, right? But every visit he's going to add how much?
25. Well, 15.
15 if he's a member. And so that idea of repeated addition is multiplication. That's how much it costs him to go visit. How much does he want to spend?
More than 100.
No more than 100, so less than or equal to 100. That's how I wrote that inequality.
Yeah.
And then I just solved it, and when I solve it, I get this answer. In a similar way, CJ, if he's paying normal admission, right? He doesn't pay any upfront fee, but every time he goes, he pays $25. So one trip is 25, a second trip is 25, a third trip is 25, and he's going to repeatedly add, so he is multiplying, right? So 25V is less than or equal to 100, right? Because both of those are based on the $100. But if he moves down here, he increases his budget to 160. Notice it's still 50 plus 15V is less than or equal to 160 now. 25V is less than or equal to 160. The point of this is to notice when his budget's 100, it's actually better for him to pay normal admission.
It's equal to.
Huh?
Oh, I was doing a V.
Well, remember it's less than or equal to, so when you divide, it's 4. But V is less than or equal to 4.
But you multiply 25 times V, and you say V is 4.
What's the inverse of multiplication?
Oh,
So we're going to divide by 25, so V is less than or equal to 4. So, because notice the idea is that if he goes for less than or equal to 4 visits, he's going under his $100. But CJ, the point is to notice, if he's only budgeting 100, it's better to go pay each time he goes. But if he budgets 160, he can actually get more visits by paying the one-time fee. And those are like the legitimate considerations that we want to think about as people, because sometimes it makes more sense to pay a membership so you actually pay less overall. For instance, my wife and I did the cost-benefit analysis, and it's better for us to pay the membership to Costco, and we drive over to Birmingham once a month or so and go to Costco to actually buy a lot of our groceries and things like that. It was cheaper than just going to Publix every time. Saves us money. So does that help explain some things though, CJ? One thing I do want to point out is this. On all three of those, first off, 3.3 repeating, but really I say he can make 3 or less trips. Why?
Because in order to make more than 3 trips, you'd be going over.
Okay, so 1, if he goes over those 3 trips, he'd go over his budget, right? V has to be less than or equal to 10/3. But why did I go down, why did I go to 3? Why didn't I leave it as 3.3 repeating? Yeah, can you make half a trip? Are they going to charge you for going a short day? No. One last thing I do want to point out is this. If V had been less than or equal to 7.89, would I say it's 7 or less trips, or would I say 8 or less trips?
8.
Why is that?
You round.
Okay. Anyone have a differing opinion, or we all agree that it'd be 8 or less?
8.
Because you're rounding? But I want you to think about this. V has to be less than or equal to 7.89.
But, two.
Is 8 less than or equal to 7.89?
No.
So could you go up to 8 trips?
No.
No, you'd be going over budget. Notice it's important to realize, even though that's really darn close to 8, 8 would not make this inequality true, so I have to go with 7 or less. We go with that idea? Similarly, if I had V is greater than or equal to 4.1, Should I go 4 or more, or should I do 5 or more? 5 or more. It has to be greater than 4.1. So I'd have to go with 5 or more. Does that make that clear?
Yeah, I ain't know what V was.
Yeah. Well, it's just in general though. It doesn't even matter what V is. I have to recognize because it's less than or equal to, I got to go below that 7.89. Because it has to be greater than or equal to 4.1, I have to go above that 4.1. Okay? At least if it's whole numbers. Okay. We're not going to spend a ton of time here. And this is a really important skill in order to be ready for next unit, which we are starting next unit on Monday because you'll have a test on Friday or Thursday for some of us. Please notice this has a topic called solving systems of equations by graphing. Systems of equations and inequalities is what next unit is all about.
So we will be solving in graph now.
Because we'll look here, right? Y equals 2x plus 5. How many variables are there?
2.
2. So how many solutions are there if there's 2 variables?
2.
Nope. Nope.
3.
Nope. Nope.
What about?
I want you to think about this. This is the equation of a... Come on, y equals 2x plus 5. We should recognize that.
Point slope intercept.
There's point slope, and then there is slope.
Intercept.
Which one is this?
Point slope.
What do you think the point would be in this case?
5.
Is 5 on its own a point?
X. 2x.
But remember, we're multiplying there, so that's repeated
Addition.
addition, which an additive rate of change is a slope.
It'll be y.
That's a variable. Point slope was y equals, remember there's an x and a y value. Slope intercept is y equals mx plus b.
So we don't know.
Yeah, you do. Y equals mx plus b. Slope intercept. Right? Notice I have a y-intercept of 5.
Okay.
And then the slope is
2.
2. Or 2 over 1. So up 2 to the right 1. Up 2 to the right 1. Or down 2 to the left 1. But I want you to notice, and this is a key detail we need to notice here. This is the slope-intercept form of a what? What is this thing called?
Linear function.
So a line. We need to remember that multiplication is repeated addition. That's a linear function, a line. Right? Now this is critical. I need you to pay attention to this. I am graphing all of these points. What do all of those points do to this equation?
They can be placed into it, like.
They can be placed into it. Let's look at 0, 5. So the x value is 0, the y value is 5. 5 is equal to 2 times 0 plus 5. So 5 is equal to 0 plus 5. That point made this equation true. What do we call a thing that makes an equation true? What?
Solution.
A solution. Let's pick this point down here. Actually, let's not pick that one yet. Let's pick this one. 2, 9. Does 9 equal 2 times 2 plus 5? No, so that's me plugging in my x and my y.
Yes. It is.
So that point makes the equation true. Any guesses what this point will do?
Make it true.
It'll make it true. So every point on this line makes this equation
true.
True. So how many solutions are there to this?
A lot.
Not just a lot. Say it louder.
Infinitely.
Because the arrow.
The arrows is going to keep going. It's not just that though. Here's a point. Here's a point. Here's a point. Here's a point. The reason why we make it a line is because everything in between those points makes the equation true. That's infinitely many points. Infinitely many solutions. So now I want you to notice this. Well, first off, is this easy to graph as it is?
No.
You can do it,
No.
but it's not easy because it's not in
What slope intercept?
slope intercept. Point slope is useful, but slope intercept is the easiest. I want you to notice what is on its own when you have slope intercept.
Y.
So notice what I did. That gives me a 0. 0 plus y?
Y.
Y. Equals x plus 1. How many x's are right here?
1.
So that's 1x, so my slope is 1. A y-intercept of 1, a slope of 1. There it is. And then a slope of 1. Again, how many solutions does this have? Infinitely many, right? Now, it will remind you, you don't have to, bless you, you don't have to know your slope and your y-intercept to be able to go off that. What you could have done is you could have just picked some points. What is negative 1 plus 1? 0. You see how I just plugged in my x value? Is that a point on this graph? Negative 1, 0? If I plug in a 0, what is 0 plus 1? What is 1 plus 1? 2 plus 1. See how we can just plug in x values to get y values out, and then you just plot the points. It's either way that you want it. Remember, if you're not comfortable just looking at the equation, making the graph, cool, make a different mathematical representation. Okay, now here is what I need you to pay attention to, and this is actually most important. Say, I need you to be more careful with your lines. If you need to, get a ruler or something, use the edge of a binder, but you need to have straight lines. Okay? Because otherwise it's going to mess you up on stuff like this. Now, what I need you to notice right here is it says identify the point of intersection. That is right here at negative 4, comma, negative 3. That is a point of intersection. Which line is that point on? It's on both of them. So that single point makes both equations true. That's the solution to the system. See how they're grouped together? That's the solution to the system. If you check by plugging it in, does negative 3 equal negative 8 plus 5? So that makes the first equation true, right? If I plug that point into here, a negative times negative 4 plus a negative 3 equals 1. So a negative times a negative is, so that's a positive 4. When you add a negative, that's the same as subtracting. Is 4 minus 3 equal to 1? So does that point make the second equation true?
Yes.
So that's what you need to notice, because you're going to have a practice problem with that tonight for homework. Tomorrow night, you'll have another one for homework, and on Thursday, that's going to be a check for accuracy. But I need you to notice, right, that is a system, and that we're looking for that point of intersection, the point that makes both equations true. If you're stuck on that tonight, check the video, because I'm recording now. You can look at it on YouTube. All right. In just a second, while y'all are checking your next set of problems, I'm going to be passing some homeworks back. However, I'm going to go ahead and make a note right here and right now. These were some of the roughest understanding checks we've had, which I know that things have been a little weird because of COVID and all that stuff with football, so on and so forth. However, almost every single homework that I'm giving back today, I made one single note on. How are you going to get better at these skills if you aren't practicing at home? I need you to fundamentally understand something. This homework is not because I'm trying to be a jerk. It's not because I'm trying to take up your time or anything like that. First off, I want you to be aware of something, because I asked a whole bunch of teachers this last Friday just to make sure I wasn't crazy. Ms. Gentili was in here earlier today, and I asked her in front of everyone, I was like, hey, Ms. Gentili, what would you say is the minimum number of math homework questions you had every night when you were in high school? What do y'all think the answer is? 5 to 10?
20.
15 was her response. Have you ever had 15 homework questions for me?
No.
No.
No, we had like 2, 3.
Yeah. For me, when I was in high school, it was 20 to 25 a night.
Oh.
So when I ask you to do 2 to 3, or maybe even 5,
So short.
am I asking you to spend a ton of time on it?
No, sir.
No. Okay? I know that some teachers don't ask you to do homework, but please hear me very clearly on this. I do because I care. If you come in here and you look at this problem and you haven't even tried to do it, are you going to know what questions you need to ask? Are you going to know whether you understand it? No. Homework is not a punishment. Homework is one of the best things to help you get better prepared. We all get with that idea? This is designed to help you get better at these skills. Take advantage of it, get better at it, and be successful. You don't know what questions to ask if you didn't even try. You don't know whether you know how to do it or not. Another detail I want to point out is, if you ever look at any set of homeworks, there's always a topic for it. Solving systems of equations by graphing. It's a topic that has been researched to say, hey, if you just Google that topic, resources will come up to help you. You could look at that topic on Khan Academy. There's great resources there. I even found out last night or today, one of the two, I think it was this morning, if you actually go to, this is called Mathematics Vision Project, it's in the bottom right hand corner. If you go to their website, they have ready-made videos to help you get through the homework and understand the homework and why it's there. Now I will say, that service costs $24 for the entire year. But if you want those videos and you want to spend the $24 to get the help, go for it. I have free tutoring every day, but if you want to spend the money, go for it. Okay? It's your choice. I'm not trying to hold you back. I'm trying to help you be successful.
You said $23?
$24 for the whole year.
Yeah. So you got the money, you rich. I'm not even gonna do
You
it.
work this access, be quiet.
I'm not, look, I'm just saying if you want help and you're not willing to come to free tutoring, it's there. $24, that's all it is. If you want that information on how to get there, be my guest, come talk with me, and I'll be more than happy to help you.
I'm good.
Zay, you could also try like splitting the cost with somebody.
Who's gonna split it with?
I don't know, I teach like 50, 60 kids and now
You
it's
work
one
this
B.
access, dude. Yeah, like you ain't got no money.
Dude, I'm broke, dude. Trying to save.
Alright, here are the last set of homework questions. Go ahead and check these. If you did not get the homework done, quickly copy down just the answers so you can get the practice in later and make sure that you understand how to get these answers. Because you need something to compare against.
These are like sheets. That be struggling to try to find which one you want.
This is the set section.
Let me turn that in, Mr.
Hmm?
Let me turn that in.
Right.
Yeah, I don't know. We need,
Three right there.
And I was trying to get the other one too.
Focus on checking your answers right now. Alright. What questions do you have? Remember, just copy down the final answer if you didn't already try it. Try to worry about that later. Which of these do we need to talk about?
oh, tomorrow newspaper?
No, on this homework that you're supposed to be checking right now, dude. Yes, CJ. Come look at it. What's happening between the -5 and the x? Those two things are not being added or subtracted. There's nothing in between them, so we understand it to be multiplication. Right? So we need to remember that -5x, that's the same thing as -5 times x. So you should have divided. Does that make sense? Alright, any other questions?
I bet you see what you did for me.
Number 3, I divided by negative 5. It was negative 5 times x, so I divided by negative 5. Yep. Alright, we're about to move forward, so we got to get to today's lesson. Any questions? Remember, just copy down the final answers, not the work. Stop wasting class time. Especially if you did not do the homework when you were supposed to. Alright, ready to move forward?
I'm getting behind. Yeah, I gotta move forward.
Okay. So, we're about to look at our objectives for this task. If you were not here last Friday, I did realize the other day I have not uploaded all the solutions for this unit, but if you go into Schoology and you click on Unit 2 Materials or Unit 2 Equations and Inequalities, you'll actually see a folder that has solutions for everything we've done with this unit. So if there's something you're missing or something you have a question about, you can go into that folder and you can see the solutions for the past materials with some extra notes there and things like that to help you get better at this. I want you to be successful, so I'm going to provide those solution sets for you. But I need you to try these things ahead of time so that when you get to it, you're like, I didn't know how to do it. Oh, this makes sense now. Or, man, I still don't know how to do it. Let me ask Mr. Kinney a little bit more information. So we're going to look at our objectives. We're going to relaunch 4.6 and then work in groups for the rest of the day. RJ, can I get you to read the first objective for us today?
A reasonable find each step of solving inequalities to the inequalities.
Okay, we're focusing on inequalities, but I do want you to notice, am I just asking you to work out like 50 different inequalities and you just practice them over and over and over again? No, because that's boring. No one wants to do it. I get it. But learning how to reason and explain things, that's a skill that's going to be useful whether you go into the job force, if you go into college, whatever you want. This is good. We need to reason and explain things. Amity, can you read the second objective for us today?
I can identify the differences and similarities between solving equations and inequalities.
We have a test on equations and inequalities at the end of this unit, right? Pretty soon. What are you trying to hand me? That's not for me.
You didn't put my phone?
Oh,
that's wrong.
We'll turn into the back in a second. And I think we can agree at this point, equations and inequalities is pretty similar, right? But are there some small differences? Can we mess up if we don't pay attention to those small differences? So that's why we're paying attention to this and we're focused on this today. And so we really need to pay attention. Okay, so Joaquin and Serena, they were working together. This is how we're supposed to work within our group, so talking through ideas. If we disagree, we need to explain why we disagree and try to convince the other person of why we think we're right. Because if we cannot convince them, man, maybe we're making a mistake. So talk with each other, try to convince each other of what you think is correct. What was the last question y'all got to in group 2 on Friday? Or were we all one group last week? Last Friday? Y'all were here, weren't you, for football?
Huh?
Or did y'all?
I was here.
You were here, Trey?
I
So it was 2 and 2.
Wait, what page?
This would be page 2 at the top. Number 3 there. Next page at the top left. How far did you get? You just got to number 3. You didn't get to number 4. Did you finish number 3?
Yes.
Okay. Y'all got to number 4? Okay, let's quickly go over 4 so that we're all on the same page, and then you'll start on number 5. So Joaquin is thinking hard about equations and equality and comes up with this idea. If 45 plus 47 is equal to t, then t is equal to 45 plus 47. Can you just flip it around when it's an equation? Yeah, notice that's 92 is equal to t versus t is equal to 92. It doesn't matter what you're saying t equals 92, right? So he then says, if 45 plus 47 is less than t, then t is less than 45 plus 47. Is he right in making this statement? So Amity, you say no. Why did you say no?
Because t can't be less than 45 plus 47.
Notice in this one, t, or that's 45 plus 47, or 92, is less than t, which means t is
More than.
more than 92, right? But in this one, it is saying t is less than 92. So we would disagree. Okay? And these are things that we want to pay attention to. I think one of the things I asked students to do in their small groups last week was say, hey, if 92 is less than t, what is the solution to this inequality? And I think a lot of groups were coming up with something like 100. So is 92 less than 100? Yes. Here, though, is 100 less than 92? No, that's not a true statement, right? So the solutions for one are not the solutions for the other. And what we need to pay attention to about this is, if you flip the expressions, you need to do what to the inequality? And so the way we say that is reverse the direction. Right, so if you flip those expressions, you need to reverse the direction of the inequality. It shouldn't be t is less than that, it should have been t is greater than. We go with that idea. Okay. So now we can all start off on 45, or no, 45, on number 5 together. I'm going to leave those notes over there for now, so that if you need them, you can get them. So notice that idea, though, is driving Joaquin's question number 4, is now making Serena think about other similarities and differences in equations and inequalities. Notice, remember, this is the objective. We want to know how equations and inequalities are alike and how they're different. And so Serena wonders about the equation negative x divided by 3 equals 4. And she wants to know how is that similar and how is that different to negative x divided by 3 is greater than 4. So here's what I want you to do, because this is an important thing. I want you to think about, hey, what is similar and what is different about this equation and this inequality. With that, Zay, did you finish getting this copy down?
Yes, sir.
Okay. With that, don't just kind of stare at it. How are they similar, how are they different when solving? How are they similar and how are they different in terms of their solutions? So you need the similarities, you need the differences for both solving and for the solutions. We all good with that? All right, go ahead and start looking over it, thinking over it, and then talking with your group.